Let's see one example. We consider the differential equation, derivative of y with respect to x is equal to 3y plus 3. This is a differential equation, and it's a first order one. For the part A of this example, we want to show that a given function is a solution of the differential equation. So what we're going to do is we're going to check that that function verifies the differential equation. So let me write it here again. The function is given by c times e to the 3x minus 1. This is the function y. We need to relate it to its derivative with respect to x. So let's consider the derivative of y with respect to x. So we're going to have c times 3 times e to the 3x. I'm applying the chain rule, and then derivative of negative 1, that's 0. So now we want to check that we get the same by considering this derivative and by considering 3 times the function, so 3 times c times e to the 3x minus 1 plus 3. We want to check that this is true. So in the right hand side here we have 3 times c times e to the 3x. And then we have 3 multiplied by negative 1, negative 3 plus 3. So we have the constants cancelling, and we did indeed get the same as the derivative of the function with respect to x. So we show that for each value c, the function y equals c times e to the 3x minus 1 is a solution of the differential equation. Now we want to sketch how those functions look like when for some values of c, and here I'm moving to doing this work with the calculator. Remember that this is paper 3 we are dealing with, and paper 3 is a calculator paper, so we're going to sketch these functions in the calculator. Since we want to sketch the solutions curves for 5 different values of c, I'm going to try to do this in the calculator in the most efficient possible way. So what I did over here was to define a function of x and c, y of xc. So we have the variable x and we have also the parameter c. And I entered that definition, and I checked that when c is equal to 0, I get the constant function negative 1, and when x is equal to 1, I get the function e to the power of 3x minus 1. So I want to graph 5 of those functions. So I have over here a graph page, and then I want my first function to be y of x 0. Notice that we have the bold y because the calculator is recognizing that that's something that I already defined. Yep, that's a function negative 1. That was what I wanted. I also want y of x1. It's over there. And I also want y of x negative 1 and y of x2 and y of x negative 2. So there are my functions. I'm going to try to zoom in a little bit so I can see them a little bit more clear. Center over here. Yeah. Okay, so we have now, well, it looks a bit messy with all the labels over here, what the functions are. But nevertheless, we have all the functions we need over there, and now we can do the sketch in our own page. So let's move over here. Those are my axes, 4x and y. I'll begin with the function constant negative 1. That's y equals negative 1. We have the first one of the functions over there. gonna do the second one as well. They both have horizontal asymptote at y equals -1. This is the one with the 2 multiplying it to the 3x. And now the other two that I'm missing are symmetric with respect to the two we have over here. So one is over here, and this is the one with the -1. And then I need the more steep one over here.